So what I want to do today is we're going to start with something called the gradient formula. So in the previous lesson, we spoke about this thing called the Cartesian plane, and it had an x-axis and we had what's called a y-axis. And we spoke about points on the Cartesian plane. So maybe this point over here would be A, and it could be the point 1, 2, and maybe we would have another point over here. We'll call that point B, and 1, 2, 3, 4, 5 across, 3 up. So the coordinates for that would be 5, 3. An important idea in coordinate geometry is knowing how to find the gradient between 2 points. So this line has a slope. If you imagine it, that wouldn't be too bad to climb. And so can we work out the gradient of the line segment between A and B? And also, if we had something like a point up here, let's call this point C, that would, what would the coordinate be? 1, 2, 3, 4, 5, 6, 7. So C's coordinate would be 4, 7. We can see that the gradient of AC is definitely a lot deeper than AB, but we need to have a way of working out what that is. Okay, so what is the gradient formula? We use the symbol M normally for gradient, and we talk about rise over run. Often students change in Y over change in X. And that's all good and well, it makes sense. But in reality, the formula used the most is y2 minus y1 over x2 minus x1, which looks like a bit of a mouthful. So what does that actually mean? Well, let me show you. If we look to find the gradient between A and B, what are the 2 points that I need to think about? There's 5, 3, and there's 1, 2. And so what I do is I make sure I go to the top. Let me choose a different color, not to confuse anyone. And I look at the top and I know the Y part is on top. So I say Y2, so I go 3 minus 2. 3 minus 2. And then on the X part, it's going to be 5 minus 1. And so we say the gradient is from A to B is 1 over 4. And what that means is that to stay on the line, we need to go across by 4 and up by 1 in terms of how the gradient is built. Now, that is the flatter of the 2 lines. I would like you to try, using just what I've showed you now, to find the gradient of the line AC. And I'm hoping that it's a bigger number because it looks steeper to me. So over to the students, can you work out the gradient of AC? It's the red line. And then while students are working on that, if there are any questions, I'm happy to try and answer them as best I can. Okay, I see lots of answers coming in. And what we see is that the gradient of the line AC, or the line segment AC, is going to be 5 over 3. And that makes me happy because like 5 over 3 is a much bigger number than 1 over 4. And that makes sense because you can see the number is steeper over here. Another way of thinking about this also is that, well, actually, yeah, let's stay with that for now. All right, now I'm going to make up two other points. I'm going to put a point down here, and I'm going to call this point D, and its coordinates are 2 minus 2. And I'm also going to make another point up here called E, and these coordinates 1, 2, 3, 4, 4 across, 3 up. So this is going to be minus 4, 3. I want you to work out for me what is the gradient of the line DE. But you're doing very nicely. I like what I'm seeing. And for those students who are feeling unsure, please do let me know in the chats or ask a question, and I will assist you where I can. Or just pop your hand up for a chat. I like to have a chat with a student every now and again if you're feeling chatty. There's actually two different ways we could do this. Some of you will start with D, some of you will start with E. It doesn't matter as long as you're consistent. So I'm going to start with D, but yeah, you could have done it a number of ways. So I make sure I'm with my Y's first, minus 2, minus 3. And then on the bottom, I'm going to have 2, 2 minus 4. And then on the bottom, I'm going to get 2 plus 4 then, which is 6. And on the top, I'm going to get minus 5 over 6, or 5 over minus 6. Either way, you're going to get that. Now, I'm happy that I got a negative, because one of the things that when we talk about gradient, if it's sloping down to the right, it's almost like you're going down here, then it's a negative, or another way of seeing it is going up to the left, I guess you could also say. So this is the negative direction, whereas the other ones over here going up to the right is the positive direction. And so the fact that I see a negative makes me very happy, like we're doing the right thing. Okay, I think you guys have got the basics of the gradient formula, but I just want to have a quick check. Thumbs up if you feel okay with the basics of the gradient formula. Thumbs down if you feel unsure. Just want to get a feel for the group. To be honest, it is helpful for me because I can't always see all your faces all the time. Okay. Well, let's do a couple of multiple choice questions just to look at gradients in a different way. So I want you to tell me what is the gradient or slope of this line segment. Now, there's no points on it, but so you have to use some other thinking, but see what you can figure out from what we've done so far. You can use some other, like I said, you can use M can also be rise over run. It could be the change in Y over the change in X, or it could be this formula that I was talking about. But that works better when you have a Cartesian plane. Now, which one is it going to be? I'll pretend I have a point here and a point here. So I count 4. So I'm pretty confident it must be positive because it's sloping up to the right. And then my change in y is 2. That's how much it goes up by. So that's going to be a 2. And my change in x, or my horizontal change, is going to be 4. So let's put that in. Is there anything here that's 2 over 4? No. But an equivalent fraction for 2 over 4 is a half. And is there a half? There it is. So the gradient here is going to be a half. And you can see this if you go 2 across, 1 up, you're on the line. And then 2 across, 1 up, you can see how the gradient of a half looks like. Cool. So I caught a couple of you there, but I think it's because of the type of question. So we're going to do another one like this. But I think most of you have got the basic idea of this type of question. So let's try another one like this. What is the gradient or slope of this line segment? Who's feeling brave? Who would like to share their answer with me? I see people are they voting already. Where should I start? I was thinking I need to know like this stuff. I need to count some blocks. So 5 there and 3 there. Okay, so Sylvia, don't worry, Sylvia. I put this in on purpose because I wanted to make sure that you understand what gradient is. So if you think of the change, the horizontal change and the vertical change. So the way we write the vertical change is the change in y, and that change in y is this bit here. Another way of saying it is the rise, but there's different teachers call it different things in different grades. So I want to suggest that this is a change in 5 in the vertical and a change in 3, but there's one catch. There's one catch here. It's not going up to the right, it's coming down, and so it has to be a negative. Now, I still don't see any answer that is like this, but I've just remembered that improper fractions can be converted into mixed numbers. So which one will match minus 5 over 3? Would it be this one, this one? Which one do you think will match? So I think, how many times does 3 go into 5? So I know it's a minus. 3 goes into 5 once, and there's 2 left over. And so I get minus 1 and 2/3. Let's do one more like this. Is not super common, but it's important that you understand it for what gradient means. And so we get the answer A. Okay, let's do one like this. Get rid of that. Oop. Move this across. I don't know why this thing won't go away. Okay, what is the gradient of this line over here? You have a choice between A, B, C, or D. And this time, fortunately, you have the Cartesian plane to help you. So I suppose you could choose 2 points if you like. You could take them, or you could just count blocks. Like, what would that coordinate be? That looks to me like it's 0, 2. And this one is. What do you think the gradient of this straight line is? I'd love to hear from students because there's different ways you can do this. And so who would like to share how they're doing it? I'd love to hear from students. Which way did you use, or what thinking were you using when you tried to answer this question? I see a nice mixture of answers in the chat. Who would like to share their Mbaza, would you be willing to share, or Annie, or what thinking are you using when you do this? Well, how do you approach this problem? Maybe you can help some of the other students here. There's probably two ways. The one way to do it is to use the formula. So you could go 5 minus 2. Well, yeah, 5 minus 2 over 1 minus 0, which would give us 3. Or we could count the blocks and go 1 across and 3 up, or 3 over 1, and we'd also get an answer of 3. So both ways would work. The good news is both ways do work, and you get M is 3. Orikanisa, let's go to you.
Hi, sir.
Hey, how's it going?
I'm fine, thanks. And how are you?
I'm very good, very good.
So I wanted to ask,
Yeah.
is it possible to use the line that?
Okay. I think we
The
lost
other line, the
the
other
other.
half line. Oh, okay.
So I think I got the most of what you were saying. Is it possible to use other points on the line? And yes, it is. It is possible to use other points on the line. So Annie's asked, sir, will it work if we create our own points? Yes, it will. So you could have also used this point and let's say that point over there, right? And it would still work as long as you are basically being consistent. Okay. We don't have to get too stressed about this. Let's do one more of these and then we'll move on. And also it seems to have frozen. So let me just quickly change screens and see if I can get it to go away. No, it's really wanting to stay. I've made it angry. Let me move this. What can I do to appease my one? Okay, I think let me go. Ugh. Sorry, guys. I'll go here. Let me quickly. Why is it not working? What clever way do I have of solving this problem? I think changing to text mode and changing back to. Nope. Can't go. Okay, I tell you what, you guys, can you see this? I think you can see the question on the screen. Can we just do this last one here? What is the gradient of the following line? And I will try and get rid of the funny writing that's in the way. Cool. So everyone, what is the slope of the following line? And then can you see that in the background there what the question looks like? Give it a go. Oh, there we go. Oh, thank goodness. So Can you hear me okay? Just want to check if I'm having internet connection issues or...
Yes, we can still hear you, James.
Okay, cool. So if we wanted to work out the gradient of this line, there's two ways we could do it, but you do need some points on the line. And so I'm going to choose this point and say like that point. But there are other ways of doing that. So that point over there looks to me like 0, 1, and this point looks like it's 1 minus 4. And the only reason I chose those points is they were exactly on the line. But I could have also chosen a point up here as well. I can enlarge the screen. Yes, I can. Let me see if I can do that. That makes life a bit easier. What do we think the gradient of this line is? I think it's negative by just looking at it. But so if we're doing the sort of formula way, we would go this minus this, and this minus this. So minus 4 minus 1, and then 1 minus 0, which gives me minus 5. Now, the answer has to be A because it's sloping down and to the right. A positive 5 would have had to be going in that direction. So give me a thumbs up if you understand why this graph has to be negative, whereas this one over here, this one would have to be positive. Just want to make sure you understand the difference. So if we have a Cartesian plane, a line that goes this way, like these ones, their gradient will always be positive. But if your line is sloping like that way, then gradient will be negative. Okay. Let's do one more of these, and then we can, in fact, let's do one with a, where is it? Actually, you know what? Let me just, I want you to find me the gradient of that line over there, the green one. And I also want you to find me the gradient of this line over here, the pink one. And then we're going to take a break. So find me the gradient of CD and find me the gradient of GH. Over to my students. Aha, nice, Naomi. Nice, Artie. Let's have a look. Keep those answers coming in the chat, guys and girls. Let me start with G. Ooh, have I made a mistake here? what's going on here? -1 minus 4 is +4. Oh, that's correct. Yeah. The negative +1 plus 4 give me 3 over 4. So GH for me, I get 3 over 4. So watch out for that. -1 minus -4. I know what's catching you guys. It's the double negative. Watch out for this. So that double negative becomes a positive, and that's what's catching you a little bit. And what about CD? So I'll start with this one over here. 3 minus 1 on top, because it's the y's that we always do first, and then on the bottom it's -5, and now watch out for this, minus -1, because remember the gradient formula has subtractions in it. So we have 2 over -5 plus 1, which should then give us -2 over 4, or simplified, we get -1/2. All right, so we've got two really quite interesting gradient questions. I'd like a little poll from the class. Thumbs up if you're feeling generally comfortable with the idea of gradient, and thumbs down if you're still feeling a bit unsure. I just want to point out that the green graph is a positive gradient. It's going up to the right. The pink graph is a negative gradient because it's sloping down to the right. And so, yeah, give us some honest feedback in the chat just so we know how you're feeling. All right. Don't worry, we will practice this more. There's plenty more to come. But let us all take a moment to stand to our feet. Please turn your cameras on. And we are going to just take a moment to be human beings and unwind for a second so that our bodies, so our brains can carry on working. And stand up and lift your legs nice and high if you can. Oh, you see, I'm not sure if you can see my legs, but anyway, see if you can lift your knees up like this. You should feel a bit of a crunch in your stomach. Oh, there we go. I can definitely feel that. Oh, your hamstrings too. Okay, then give it a quick little swing around, gently at first, and then as you relax, let your body turn the whole way around. Oh, that feels good. I can feel my body unwinding. Okay, shake it out. Shake it out. And then stretch. Feel those shoulders become less tense. And let's do this. Okay. And then let's just do some of these big circles to small circles. And then change direction, small circles, back to big circles. Okay. All right. And then a high heart rate activity. Let's see if we can do. We're going to do, okay, this is going to hurt, guys. We're going to do it. So we're going to do knee-high touches. So what we're going to do is we go 1, 2, like this. So your legs have to kick up and you have to touch sort of your hands. And we're going to do 20. So 3, 2, 1, let's go. 7, 8, 9, 10.
I'm wearing jeans on the stairs. I think I'll sit this out.
Yeah, that's hard because your quads have to really get up. Let me stop before I injure myself. Okay, let's do a little math 24. So just for a little break, can you make 24 using these 4 numbers? You know, maybe I got a bit carried away there, Annie. But you know how it is. I like to do something different, and I was getting bored of the jumping jacks, even though I know they're good. Okay, let's make 24 using these 4 numbers. For those who are new, this is a little game we play just to break up our concentration. We try and make 24 using the 4 numbers, and we have to use all of them. So in Nkosi, I like what you've done there, but I think you've only used 3 numbers. Let's have a look. 6 times 3. Oh, but we
combine the 8.
Oh, yes. Okay. So Nkosi has said 6 times 3 plus 4 times 2. And then that would give you 18 plus 6, which is 24. Wait, I lie. That's going to give you 26. I'm talking rubbish. Plus 4 plus 2. So that will work. 6 times 3 plus 4 plus 2. Yes, Philosiwa and Lolita agree. All right, cool. And Luyanda also agrees. Fantastic. So that is
nicely done, guys.
Maths game called Maths 24. And for those new students who are joining us today for the first time, we play this. We try and play this almost every time if we can. It's just a little good thing for our mental multiplication. Okay, now into the second half of the lesson. And we're going to carry on with this next week. And that's straight lines. So you'll notice that earlier in the lesson, I gave you the formula for the gradient. But now I want to know from you, and you've probably heard about this before, what is the formula for a straight line? Who would like to tell me? I'm dying to hear a student voice. What is the formula for a straight line? Yes, let's go to Orikanisa. Let's unmute Orikanisa. What is the formula for a straight line?
The formula for a straight line is y minus y1 equals to m bracket x minus x1. Or you can use the other formula which says y equals to mx plus c.
Yo, top student. Thank you so much. So these are the 2 ways of writing the equation of a straight line. Normally, this is an intermediate phase at the beginning, and then we end up kind of with this one. There's 2 ways to find the equation of a straight line, which I'll show you now. But I want to ask about 2 of them. I see there's an M here, and I see also there is a C here. Does anybody know what those things stand for? Let's unmute Togotso.
So the M is for the gradient and the C is for the y-intercept.
Okay, so the M is for the gradient and the C is for the y-intercept. And the M, the gradient, is the gradient that we've just been working out now. So in order to find the equation of a straight line, you need the gradient and a y-intercept. Or if you have the gradient and one other point, so in this thing here, we have this x1 and y1. That is a point that is on the line. And so if you have a point on the straight line, you can use that point using the formula here to find the equation of the straight line. But the best way to do this is to practice. So take a screenshot if you need to of this screen, but we're going to first check you know how to find the y-intercepts, and then we're going to find the equations of straight lines. Okay, so take your screenshots if you need to, and we're going to practice using this formula now. So first of all, I want to know, what is the y-intercept of the following straight line? What is the y-intercept of the following straight line? So look at everyone go. Students are definitely recognizing that this is the y-intercept over here, and that is 4. And if we have to choose an option that relates that 4, it's going to be C. Okay, now, I said to you that in order to find the equation of the straight line, you needed M and you needed C. Can you figure out the equation of this straight line using what you've learned so far in today's lesson? You've just told me that you've worked out what C is. Let me get this. You told me you've worked out what C is. Surely all you need to do is work out what M is, and then you've got the equation of the straight line. See if you can figure out the equation of the straight line and then write it in the chat. Or I'd love to hear from a student if you feel like you know. What is the equation of this straight line? Maybe someone can give me a tip. What should I be looking to figure out? Who's willing to give us a tip? So I've got C, it's the y-intercept. We learned that earlier in the lesson. We can see that, in fact, let's zoom out for a second. We can see that C is the y-intercept. I want to know what is the equation of this line over here. I was thinking, don't we need to find the gradient? Yeah, and of course he agrees. So if we wanted to know the gradient, there's 2 ways we could do it. We could either do it by using a formula, we had 2 points, or we could count and we could look at, let's say, these 2 points here. So I'm pretty confident the gradient will be negative because it's sloping down. Peleng agrees, get the gradient. So let's see, if I start here and I go here, it feels to me like I'm going down by 3 and across by 4. Careful. So down by 3, across by 4, because I'm choosing these 2 points here. So I've gone down by 3 and across by 4. I know some of you are saying 4. Oh, you could get 4 over. Oh no, this doesn't fit. Everyone, can you see it doesn't go exactly through 5? And so you can't use that bit there. Let me go back. But I understand why you're saying minus 4 over 5. It's just going to be actually y equals minus 3 over 4x. And then it was going through plus 4. So that would be the equation of this straight line. So I kind of, maybe that one was a bit tricky. So let me choose another one to illustrate this idea. And I'm going to do one where you just have 2 points. Okay, so, let's go to this one over here. And we'll carry on with this in the next lesson. But I want you to try and figure out which of the 4 here are the right answer for this equation of this line. Now, in order to find the equation of a straight line, you need the M and you need the C value. Which one am I going to try and get first here? Which one do you think makes the most sense to try and get hold of first here? M. Yeah. So Puleng, the reason it had to be negative was because it was sloping down and to the right. The reason that the scale on that one was a bit out. And so I think the scale was why some of you didn't understand it. So I wouldn't stress too much about that. Let's try and do this one in the time that's left, and then we'll carry on in the next lesson. So what I agree with the students is that M is the first thing I want to find. And to find the gradient here, I'm going to have to find I'm going to have to use this formula. So what is gradient going to be? So it's going to be 9 minus 5 over 4 minus 2, which is 4 over 2, which is 2. So it's not going to be this one. It's not going to be that one. So I have two remaining choices. It could be B or C. Who would like to come and explain why they knew it was either B or C? I want an explanation from someone. Yes, Annie, what is your explanation for this one? Can you hear me, Annie? I think we might have lost Annie, but I see lots of students are choosing C, and I agree with you. And the reason I know it's C is that if I look at where it cuts the y-axis, I know it has to be a positive value. And in B, there's the negative y-intercept. So I had to ignore that. Now, so the answer has to be C. But just to show you, earlier in the lesson, we had this, actually, you know what, I'll start in the next lesson, but just to show you that you can work out what C is exactly. But yeah, I think we're running out of time for me to go too much into detail with that. Let's do one more. Quick little vote, thumbs up if you're feeling okay with today, thumbs down if you're feeling a bit confused. Just want a quick little vote as to how much depth I go into in the next example. Okay. Okay, let me slow it down for a second. Okay, let's end with, this is what we're going to start the next lesson with. So if students are uncertain about finding the equations of straight lines, don't worry. The next lesson deals with finding the equations of straight lines and how we work with parallel and perpendicular. But let's just start with this question here. If I want to find the equation of a straight line, there are only two things that we need. Again, of the two options, which one should we find first? I want to suggest we find M first. So go ahead and find me M. How do we find M? We use the formula y2 minus y1 over x2 minus x1. We're going to finish with this one today. Find me the gradients. Right, so we have figured out that the gradient is 3. Now, at this point, we have a choice. There are 2 methods we can use, and I'm going to show you both, and then in the next lesson, we carry on practicing. The one method is to write down y equals 3x plus c and use another point to help me find the c. The other method that was mentioned earlier in the lesson is the y minus some point, some y points. So I'll leave a space there for that, equals the gradient. So the gradient was 3 and x minus that. So I'll put a bracket around this. So in both of these methods for finding the equation of the straight line, we have to choose a point. And I want to ask the class, what point should I use? Should I choose 1 minus 4 or should I use 3, 2? They're both on the number line. They're both on the straight line. Which one would you like me to use? Okay, Ayanda said the first one. Mojero said the first one. Okay, so if we are using the first method, we would use the point 1 minus here. And then if we were using the second method, all we do is we write this point that we're using in here. So we go over here, we're going to write a minus 4 for this bit. And over here, we're going to write a 1, which is basically just the same point we're using. In this method, I sub in the point. So this is an x and this is a y. And so I go minus 4 equals 3 times 1 plus c. And then if I move the 3 across to the other side, I get minus 4 minus 3 equals c, and c is minus 7. And so the equation of my line would be y equals 3x minus 7. So that was the one way we could do it, by subbing in a point. The other way of doing it is using this method, where we have y minus minus 4, which is y plus 4. And then on this side, we have 3 times x minus 1. So we get 3x minus 3. And good news for me, the math teacher, if I take away 4 from both sides, I'm going to get minus 7, which is the same answer. Now, this method of finding the equation of the straight line, we're going to practice more in the next lesson. So I don't want you to feel unsure or worried if you're feeling uncertain about today. Just re-watch the video before our next lesson, and then we will build on the skill set in the next lesson. So as a recap, what have we done today? We learned about gradient and what the gradient is. We learned about how to calculate the gradient using the formula. We also learned how to identify the gradient using visual diagrams and working from there. We also spoke about the formula for a straight line, which we're going to carry on with in the next lesson. And we had one example at the end here where we just calculated the equation of a straight line, and we had to find the gradient first, which was here, and then we had to find the c value, and there were 2 ways of doing that. And you can choose whichever way your teacher uses, or whichever way is most comfortable for you. Okay. That is pretty much it from me for today. So Lebo, if you could put the link to the quiz in the chat, and I will just take any final questions from students now in the remaining time. If there's anything they were unsure about today, otherwise I would recommend going off to do the quiz. And yeah, I hope that you have enjoyed the lesson. Do let us know how it felt for you, and do your quiz. It will help you reinforce your learning. So Naomi, the classes go on during the holiday time. We rock and roll every week. And in May, we're even doing Saturdays because we are helping with some extra exam revision classes. So yeah, we go on right through the whole year, every week. Awesome. Thank you. Oh, thank you so much, Ling. That is such a team player. Thank you so much. All right, everyone. I hope that you have a great long weekend.